Hello, sir. Welcome. Sir, you are in mute condition. Hello.
Oh, hello.
Yes, sir.
Hello, everyone. Good
Hello, sir.
afternoon.
Good afternoon, sir.
Could you hear me? I mean, is it clear?
Yes, yes, sir. Yes, sir. You are audible. You are
Okay.
audible.
Thanks a lot for
Thank you,
inviting
sir. Thank
me.
you for joining us, and we will be starting shortly at sharp 5 p.m. The participants are still joining.
Mm-hmm.
Okay, sir. Okay, sir. So it's 5 p.m. here. So we are just want to start our program. Uh,
Okay.
so there are so many participants who have already joined with us. Hello everyone and welcome to today's session organized by IEEE Computer Society Student Branch Chapter IIT KGP. So it's a great pleasure for me to introduce our speaker today, who is going to talk to us about introduction to Docker with hands-on experience. So let me introduce our speaker. Dr. Arif Ahmed is now associated with Ericsson Research as an experienced researcher. Before joining Ericsson, he completed Ph.D. in cloud computing from IRISA, University of Rennes, France. Before joining as a Ph.D. student at IRISA in 2016, he served as an assistant professor at the National Institute of Technology, Silchar, India. He had also worked as a visiting scientist at the Center for Development of Advanced Computing, Mumbai, India. From 2014 to 2015, he received his MTech degree in Computer Science and Engineering from the National Institute of Technology, Silchar, India in 2014, and BTech in Information and Technology from Assam University, Silchar, India in 2012. So his research fields are cloud computing, edge computing, blockchain, and Internet of Things, etc. So, dear all, please join me in welcoming Dr. Arif Ahmed, sir. Thank you, sir, for joining us. Now, I just want to tell the program flow of today's session. We will first, the sir will give a brief theoretical introduction to Docker and Kubernetes. And then we will continue with short Q&A sessions where you can ask any question to our speaker. We will deliver the question to the speaker and he will answer. And then we will do a short demonstration and hands-on session so that you can learn it by hands-on training. So I would like to request all of the participants to keep your mic and camera off, and please do not share your screen at any time. Kindly use the chat box to post your questions in Gmeet, and please do not post anything except question related and relevant for the session in the chat box. So we are happy to inform to all of you that we are also live streaming our event in our YouTube and Facebook page also. So kindly use the chat box there to ask your queries. Our dedicated team will be constantly monitoring your question in those channels. So don't worry, your question will also be answered. So I hope there are so many participants have joined through our YouTube channel and Facebook page also. So yeah, happy learning and enjoy the session. Over to you, sir. Thank you so much.
Thank you, Sricheta. And welcome again. And so today I will present this workshop on Docker, and we'll do some hands-on experience. I will now share my screen. How to share? Okay, present now. Your enters a window. Okay. Okay, can you see my screen?
Yes, sir. It's visible.
Is visible?
Yes, sir. Yes, sir. Definitely. So we can clearly see your screen.
Okay. So I will just turn to no. Now do you see? Okay. Yeah, and this workshop is on Docker and Kubernetes and container technologies. And I am very happy to be invited here, and I can share my experience, and then we will do the interesting hands-on exercise. I work in Ericsson as an experienced researcher, and I live in Stockholm, Sweden. And I basically come from Assam. Not far away from Kharagpur, but very far away from here. So today's agenda will be on 4 different sections. First one is we will talk about virtualizations, and then we'll talk about Docker, and then container orchestration, and then we'll do the hands-on experience. With the virtualizations, we will talk about the virtualization technologies, and then the VM versus container virtualizations, and how cloud and virtualization are related. In Docker, we'll talk about what is Docker, Docker architecture and its components such as image, volume, and how containers are deployed. In container orchestration, we'll talk about the need of container orchestration, and we'll talk about Kubernetes, and we'll see its architecture, and we'll see the Minikube. And in the hands-on exercise, we'll talk about the installation of Docker and Kubernetes, and we'll do some exercises which are related to Docker and Kubernetes. So let's first move to the virtualization sections. And yeah, so now discuss how do we traditionally deploy applications. If you think about, years back, most of the organizations ran applications on physical servers. So they have to buy the physical server, that is hardware, and then install operating system, and then install the application. Now, in this case, there are some disadvantages. One is that suppose that you run multiple applications, then one application would take up most of the resources. For example, when you have in your machine where you follow the traditional architecture, then maybe one day you see that the Google Chrome takes large memory, right? And then it affects the other applications, right? And so then the applications of the other application is affected, and it will not perform the required. So that is one disadvantage. The second is difficult to isolate resources. That means that since you are running multiple applications, then one application can also see the other applications, which is danger for security reasons. Suppose that the applications are from different users. There is a solution. The solution is to deploy each application in a single physical server. So you will deploy one application in one server, one physical server, and the other application in another physical server. But there are also disadvantages here. The one is expensive. So you need to buy, for each applications one server, which is too expensive. The another one is that you might not use all the resources. So since you are running only one applications in the one server, that means it is quite unlikely that all the resources will be used by that applications. And the fourth is that suppose that if the operating system fails, then all the applications will be failed. So these are some of the disadvantages of running our applications in traditional architectures. Yeah, normally we usually do this in our laptop or in our system, but for production servers, I mean, it is very very difficult. So we'll see what is virtual computing, and virtual computing is the solution of that. What do you mean by virtualizations? Virtualization actually create an abstract layer, you see, over the computer hardware that allows the hardware elements of a single computer, process, memory, and storage are divided into multiple virtual computer. So with the virtualization, you can create create on the hardware, single hardware, multiple computers. Okay, so that is virtualization. Now you see the benefit of it is that you can have multiple virtual machine on a single hardware. So the user which is running on the virtual machine, it will not feel that it is running on different with the other virtual machine. So that is one benefit, and the other benefit is that you can run multiple machines on the same hardware. So that is the other benefit. Now, different virtualization techniques are available. The first one is VM virtualization. Here, you create multiple virtual machines, multiple VMs. And the other one is container virtualization. So that we will see. I mean, it will create multiple containers. And then the network function virtualization. Here virtualizations is done for the network functions, like for filter, for security, for firewalls, for IP routing and all. And there are multiple companies that enables the virtualization. One is the VMware. OpenStack is one example. And NF, network function virtualization. I think many network companies like Ericsson also does this, and Docker, which we'll talk about more on Docker. So let's move to the benefit of virtualization. So the first benefit is that we can run multiple operating system in a single VM. Like that is one the benefit, which we can partition the hardware into multiple hardware. The second is the portability. Like, so you have a virtual machine, you can you can save the virtual machine in a single file, and then you copy that virtual machine to another machine, and then you can just turn on, you can import that, and then you can run. So you can run anywhere where the virtual machine is supported. And there is a security, since we saw that there is another layer, virtualization layer, so there is extra security. And if there is any failure in the virtual machine, you can, because of the security reason, then you can again roll back and you can recover. And then you can migrate the virtual machine in different physical server. And the last one is we can reduce cost, because we are running multiple servers in the single machine. So we don't have to buy multiple servers now. So that reduces the hardware cost. So next we'll talk about cloud and virtualization. So we know cloud, I mean, we have been using this since last 12, 13 years. So what is cloud computing? And cloud computing is nothing but the on-demand availability of computing resources, like, data, network, processor, memory. So anytime, if you have internet connection, then you can access the cloud. You can access those compute resources, and the main thing about it is that you don't have to manage, because the management is done by the cloud provider. So as a user, you don't have to buy the hardware, you don't have to buy the computer system. Okay. And we have different public cloud provider, Microsoft Azure, VMware, Amazon, which is famous, popular, Google Cloud Platform. So we have different cloud provider, and there are different services you can run, on cloud. One is the infrastructure as a service. Here it means that you will get the virtual machine, you can run operating system on that. You can install operating system in that machine. And the platform as a service, here the operating system will already be deployed. You just create some you can develop applications and all. In software as a service, you can run softwares like Google Drive. All those are software as a service. So you see the difference. Now the key features of cloud computing is the on demand. So anywhere you can, anytime you can get the service. Broad network access, anywhere you can go. You buy in India and you come to France, and then you can access. Multi-tenancy means multiple user can use the same server, so which is nothing but the we discussed earlier. Rapid elasticity means suppose that you already acquired 2 VM, say 8 core 16 gigabyte RAM, and suppose that your application needs suddenly let's say number of users are increasing, and you need let's say 50 gigabyte, and the cloud provider should provide those. If the user asks, then the cloud provider can scale the application, can add the resources in the existing one. So that is called rapid elasticity. And resource pooling is nothing but multiple users can, run on the same machine. So if you see all these, I mean, the multiple user can run on the same machine. This is nothing but the virtualization. So virtualization actually is the software that manipulates the hardware. White cloud computing refers to the service that result of that manipulation. So without virtualization, you cannot have cloud computing, because cloud is the one, virtualization is the one doing in the background. Next, we'll talk about a little VM virtualization and container virtualization. So VM virtualization, here actually the outcome is that you get a virtual computer, which is CPU, memory, and network interfaces, on top of the physical hardware system. But if you look at, may ask questions like how it's possible. So the hardware, the hardware running on the below, it actually need to support that virtualization. So it's depend on the hardware, and there is a software called hypervisor which actually separate the abstraction, that implement the abstraction and create multiple VMs. And there are two type of hypervisor. One is the type 1 hypervisor. Here, on top of the infrastructure, it runs the hypervisor, and then you can create multiple VMs. And the example of them is Jane, Hyper-V. So many of the cloud providers are using type 1 hypervisor. And the second one is the type 2 hypervisor. Type 2 hypervisor is you run on top of the host operating system. So for example, VirtualBox is one example here. If you see VirtualBox is running on top of the host operating system. So there are advantages and disadvantages of two different types. Type 1, since there is no host operating system, so it is there is a we eliminate this layer, so the performance will be better. In type 2 hypervisor, since there is a layer, that means it will impact. I mean, it will. The performance will be a little bit slow. And in virtual machine, you need to install operating system, since it's a machine, but virtually, but you need to install the operating system. So if you see, there is a guest operating system on top of the host operating system, and then you have these applications running on top of that. And if we talk about container virtualization, actually it doesn't virtualize the whole hardware. Actually, it isolates the processes running on the same operating system, also known as operating system virtualization. So this one is called VM virtualization, called hardware virtualization, and the container virtualization called is operating system virtualization. So it basically isolate the processes running on the same operating system. So to enable that isolation, it requires some features which is supported by the operating system. So operating system should enable this isolation process. And container engine, which is running on top of the operating system, is the responsible for handling the isolation. So it interacts with the operating system to isolate the processes. And Docker containers run on top of the host operating system, and they all share the host kernel. So the big difference here is that between virtual machine and the container is that in virtual machine you have the operating system in each VM. In container, the kernel, the operating system is shared with the host operating system. So you don't have the guest OS in between them. So that is the big difference, one of the big difference. And if you think about the resource utilization, since it doesn't have the OS running in between, so the memory footprint is very low. compared to that BM. And the image size of the images are in MB, so the footprint is very low. If you talk about the BM virtualization, so you have the guest OS, so in each BM you need to install guest operating system. Okay, that means you keep multiple OS, in the same hardware, and that takes each BMs, you have downloaded that virtual box, the Ubuntu BM earlier, I think in the hands-on instruction. The size is like in GBs, right? So it takes a lot of memory, and it takes a lot of time to deploy also. Not only in the memory, but also if you start the applications, creating a BM takes like a couple of minutes, and in the container it takes in few seconds. So that is also one of the reason why container virtualization is getting popular in nowadays. So let's move to the application deployment journey. So here, so traditional deployment, and then the virtualized deployment, and then the container deployment. In virtualization, you have the virtual machine, and in container, you have the container running on top of the operating systems, but they are isolated. This is the difference. You see, here they are not isolated. Here there is isolation. So now let's move on to Docker. So Docker is a tool to package, ship, run application inside container. So it is nothing but the tool where you can, create containers. You have the application, and you can package it into the container. And Docker was actually initially inspired from LXC container. LXC container is the one which is from the Linux. But it was not popular during that time because of some situation. Unlucky, I would say. And Docker, so LXC was started in 2008, and Docker started in 2013. And in 2013, the container were popular. So, and one of the key features of the Docker is that they provide API, good API. That is, and you can integrate with those API. And it is written in Go. So Go is a statically typed programming language, and which is faster. I mean, in terms of and compared to dynamically linked programming languages, and Go is written by Google. And it's an open source project. That means you can get the code, and you can you can help them. I mean, in code also. And key features is that lightweight and pluggable. Lightweight means it's easy to manage. The image size is low, so it's lightweight. You can deploy in few seconds. Pluggable means that you can integrate. You can create your own feature. You can add new features easily. Easy to share images. You will see this later on, how we can share images so easily, and large number of communities. You will see, I mean, Docker is using nowadays in 50% of the companies. In terms of benefit of application developers, CI/CD is nothing but you can suppose that you have a application developing, and multiple users are contributing on that application's development, and you can integrate easily with CI/CD, and you can test and build easily. And one of the benefit of using Docker is that you can use the same image every time you integrate, and you build, you test and build. So you don't have to use multiple image. The second is that the portability. So suppose that the developer has developed one image and develop some or containerized applications, and then they can share it and the tester can check. And rapid deployment, the image size is small. I talked about earlier also. The deployment takes in few seconds. Resource utilizations, because we don't have the operating system in between, so you can run multiple Docker containers in the same machine. Orchestration, yeah, many of the container orchestration support Docker compared to other container systems. Public registry, this is the one where we will use to share the images. If we talk about the popularity of Docker, you see 50% of the companies have container deployed in 2020. So this is the recent one. Top technologies such as Nginx, Redis, Postgres, they are using Docker, and 6 million repositories on Hub. So Docker Hub will see Docker Hub, and the users are 6 million repositories. Total number of pools in Hub at 130 billion. So these are some of the statistics of the popularity of Docker. Next, we'll talk about the Docker software stack. If we see when we run containers, in the bottom you have the infrastructure. It could be a hardware or it could be a virtual. And then you have the host operating system, and then a container runtime. That here, since you know that operating system need to support for containers, for isolations, and container engine is the one interact with that operating system to create the containers. And container engine, on top of that, it actually implements the enablers. For example, Docker image, Docker volume. So you will see this. So those are managed by the container engine. And on top of that, integrated lifecycle management is the one which interacts with the container engine. For example, Docker API, Docker client to deploy container, to create containers. So Docker client will directly call container engine. Docker build for creating image. So the integrated lifecycle management is the one which is interacting with container engine. So next we'll see how Docker achieve virtualization. So we know earlier that for container the operating system need to support the isolation. So Docker is using some of the features of Linux kernel. So Linux kernel provide some features to isolate the processes. So you see some of the Linux kernel Docker is using, and it is using via different options. Right now they are using lib container, which is on Docker has developed. And you see the namespace. Namespace is the one Linux kernel features that isolate the processes. So it creates a couple of namespace, PID namespace for process, ID network namespace for isolating network, IPC for IPC inter-process communication, mount space namespace for file system mounting, and UTS for time sharing. So the key thing is the namespace is the one isolating the containers from one another. The C group is the feature where you can give resource allocations. You can if you are running one applications and then you can say, okay, in these applications I will give only 250 megabyte of RAM. So you are allocating resources. So Linux kernel has one feature called C group. Okay, so it allows to memory. C group is the one where you can allocate memory to individual applications. Bulk IO. This is for input output. For example, read write operation. You can give maximum read write speed. And this one is for network. So you can give the network flow. You can keep the network bandwidth. Let's say that this application will upload in maximum upload speed is let's say 500 megabyte per second. And the fourth one is union file system. Union file system is nothing but where you can combine multiple layers.
Sorry for interrupting, but we have some questions from the participants. So should we ask the question now or at the end of the talk?
Is it how many questions?
There are 4 questions till now.
Okay. We can go on the later on.
Okay.
4 questions is means I have to. It will take a lot of time.
Okay, sir. Thank you.
And then you have the security features. So Docker architectures, you have the Docker server, which running the main functionalities such as creating containers and all those images network. And it can be run in a VM or physical machine. Docker provide multiple APIs to interact with Docker server. And the client is the one which is to interact with the Docker server. It's command line interface, and client send a request to, using the socket. Like you can build image, you can pull container. You can pull image, you can build image, you can create containers. And Docker registry is where the images will be shared. So we'll see what is Docker image next. So what is Docker image? So normally when you have you run applications in a traditional way on top of operating system, you need a couple of things, like you need the executable binaries, right? And then you need the libraries, packages, and configuration files, application data, etc. And what Docker does is that the Docker packages those applications requirement in something called Docker image. Okay, that is the Docker image. And so actually Docker image contains all those executable binaries and all those information. So you can say it's a bundle of applications requirement, and you can transfer, share this image. And when you create a container, you need the Docker image. How Docker images are structured. So we talk about the images. Actually Docker images are composed of multiple layers. Okay, so multiple layers. Each layer may be in a one subdirectory, but in multiple directories, each layers. But they are stacked upon one another. So we'll see the concept of why it's in the layer, why it is in layer structure. So image layers are read only. So once you have the images, you cannot modify the image layer. So they are all read only. Okay. Each layers is stacked upon one another. So the bottom layer, this is the lowest layer. I mean the bottom layer, and then you have the second layer, you have the third layer, you have the fourth layer, like that. Okay, and they are all read only. I mean, and so suppose that you create a new layer on top of this, then suppose that you want to modify the layers below this, then you need to create another layer. Okay, so each layer may add, remove, or overwrite files present in the layer below itself. So you have to create another layer on top of it if you want to modify anything below the image layers. And for these particular things, for this particular implementation, Docker uses something called copy on write mechanism. Copy on write mechanism is that, so you copy the file, you don't copy the whole layer to modify. You copy only the file that is to be modified on the top layer, and written in the new layer. So that is the copy on write mechanism. So there are lots of benefit of copy on write mechanism that you can share, since the existing layer in the below are read only. That means you can reuse those layers. Okay, so that is the one of benefit of copy on write. So for example, here this is the Ubuntu image, and you have the PHP image, and you have the here you have the JVM image. So JVM image and PHP image are sharing the Ubuntu image. Okay, so that is one benefit. of all those image layering and copy on write mechanism. And for example, here JVM is shared between the two images, Zeppelin and Spring. Suppose that if we don't have the read-only mechanism, then you need to modify all the Ubuntu image, right? You need, for JVM, you need to you will need to keep a copy of the base Ubuntu image. That means you are taking a lot of space. And one thing here is that each layer is identified with the corresponding hash. So that means you do hash of the content of the layer. So suppose here the contents is XYZ. So you do the hash, and then the identifier of the layer is the hash. So if you modify here something, then the hash will be different, right? Then you can say that, okay, this layer has been modified. So then the image is corrupt. Now Docker containers layers. So we know that Docker images are read only, right? Now suppose that container container is created using this layer, this image, and how it will modify something and where it will be stored. So Docker creates something called a read-write layer. So for each container, it will create a read-write layer, a thin layer on top of that image. And then all the modification of the image will be done in this read-write layer. And the images, the base image will be shared among the containers of the same image. Now the question is how to build a Docker image. So we know Docker image, we know how the Docker images are structured, how the containers containers layers are created. I mean, purpose of container layers, how Docker image can be built. So Docker image can be built from something called a Docker file. So Docker file is a human readable file which contains the instruction to build the image, and we can use the command docker build to create the image. The image can be built from scratch. That means there is no base image, so it will be, for example, Ubuntu was built from the scratch. And there is another, the other option is that you can build from another image. Okay, if you see the other example here, Ubuntu was base image, so it was built from the scratch, but the PHP world was built from on top of from Ubuntu. So so there are some of the instructions. I just gave an example from specify from which image you are building. So and then copy is to copy the files inside the container image in the image. And the run is to execute a command, and CMD is to execute some command when the container is start. We'll see one example when we do the hands-on exercise. How to share Docker images? So you have so suppose that you created an image and then you want to send the image to the server. Then how we'll do that? I mean, there is something called Docker registry server. So this registry server is, where you can store the images, Docker images. And one example is that the Docker Hub, it's one registry server. You can deploy your own private registry server also. It's pretty easy. You just need to run the container so Docker Hub is the public, and two operations we can do on the Docker in the Docker registry from the Docker client. It's a Docker push. Docker push is the one which uploading the image. So you can share, you can upload the image in the registry, and Docker pull is for downloading the image. Okay, so that's how we can share. There are other ways to share the images, but the most popular is to Docker pull and Docker push. Docker volume. So we know Docker image are read only, right? And Docker containers layer, which is earlier. So container layers are for writing any update of the from the container, from the image. If you want to modify, then you write in the container read write layer. But suppose that so one thing about container layer is that suppose that Docker the container has been stopped and deleted, then all the layers, I mean the container layer will also be deleted. So you cannot save all those. I mean, and suppose that you are running another. So that is also one issue. And another thing is that suppose you are running a container and then you another container want to read the data in the container file system. So another container wants to access those. So you cannot share that. So in order to share information between the containers and the container, you can mount mount from the local file system. So you have the container, you have the host machine. So from the local file system, you can mount in the container. So here this picture doesn't look it's not easy to explain, but multiple containers you can share the file. I mean, so there are three type of Docker volume, and one is that the volume which is stored in the host file system, which is managed by Docker. So here the file that is to be hosted, I mean that to be mounted, will be stored somewhere Docker, where Docker keep in secret. And the bind mount means here you can mount from anywhere of the file system. And in TMFS, so here the mounting will be from the memory. So we have three different Docker volume. Docker container deployment. So how the containers deployed. So you need the image name and the tag of the image. Tag is the version. So you give the command docker run and the name and tag. And Docker check if the image is available or not. If the image is not available, then Docker will pull the image. Once the image is pulled, then Docker will create the container. It will create namespace C group for the container and the read write layer. And then Docker will start the applications. So up to this, we have talked about Docker. We talk about Docker images. We talk about Docker components and Docker volume, and then container deployment. So next we'll move to container. Sorry, we'll move to container orchestration. Here we talk about we'll talk about what is orchestration. So sometimes you need to run application in multiple machines, right? And then it comes to the orchestration. So orchestration actually automate the configurations, management of a coordinator of computer systems and applications. So if you are running applications in multiple machines, then the orchestrator will do the management and configuration. So container orchestration is nothing but that one. I mean, for that purpose, I mean, it manages the life cycle of the containers, especially in the cloud environment where you have the multiple machines running. So the main purpose of the container orchestrations is the provisioning, creating and deploying containers. Scaling containers means you suppose that your applications need multiple containers to utilize hardware, more hardware. Then you can create multiple containers, and the networking between containers. And suppose that you want to stop and remove the containers, then orchestration can do that. Health monitoring of containers. So you can check, the orchestrator will check if there is if the container is running properly or not, and load balancing. And there are different container orchestration tools. You see the Kubernetes here and the Google Cloud Platform. They all running, I think, they all running Kubernetes. Amazon ECS, but modified. I mean, and Azure Container Services. Docker Swarm. Docker Swarm is from Docker. And yeah, there are a lot of container orchestration tools. And some of the comparisons here. So Docker Swarm, which is from Docker, only support Docker, Docker containers. Kubernetes support Docker RKT, and service discovery, master node replications. So we'll see this. So these are some of the tools, but we're using Kubernetes, which is most popular nowadays. So this was in 2018, but if you see one statistic, then Kubernetes in 2018, Kubernetes 42% were using Kubernetes, but nowadays I think it's more. I mean, this was back in 2018. So in this workshop, we'll see Kubernetes. We'll talk Kubernetes, and we'll do exercise on Kubernetes. So what is Kubernetes? Kubernetes was developed by Google, and it's a container orchestrator tool. It's an open source and for automating deployment, scale, and management of containers applications. It was also written in Go programming languages. So key objects of Kubernetes. So if we talk about, we'll see in the architecture as well. Pods. So pods is nothing but the collection of containers with the same namespace. So in Docker we have the container. In Kubernetes we call it pod. Pod is nothing but the collection of containers. Services, a set of pods. So service is nothing but the applications which, so an application may have multiple pods. So for example, a web server may have the front end applications, and then a web server, I mean, it can have database as well. So the two component will be running in two different pods, and they will be called a service. And the volume is nothing but something like Docker volume, where you can share the storage, and you can keep the storage for long term. Namespace it's like Docker namespace for isolating the resources. Kubernetes features automated deployment. So Kubernetes provide a deployment file which is in YML, so where you can write all the deployment configuration, and you can just deploy the containers. Scaling of port. So Kubernetes has something called auto scaling. So if you have if your applications required more resources, then it will create more ports, depending on the requirement. Self-healing. Suppose that you run on the one applications, and let's say the port is there is an error, there is a failure, and then but the Kubernetes handles something called self-healing. It will check the port is running properly. If it fails, then it will create another port. Okay. Automated rollout and rollback. That means suppose that you have changes something in the applications, and the port is seems like not working after you have changed, then Kubernetes can roll back to the previous version. Storage orchestration. So you can share with Kubernetes, you can create a persistent volume. That means you can store the containers informations, or you can share the file system of the local file system in the pods. And Kubernetes also handles service discovery and load balancing. Kubernetes architecture. So we know that orchestrator is mainly for managing applications running on different nodes. So we'll have multiple nodes in Kubernetes. And the first, the master node is the one like the brain, which is managing all the nodes. So master node is implement something called Kubernetes control plan, and what are there in that control plan? Communication with other node. So there is a REST API server which communicate with the other nodes. I mean all the worker nodes. Scheduler. So scheduler is, suppose that you are deploying one pod, and the scheduler will decide where it will be, running, okay, in which worker node. Replication and health monitoring. So control manager actually perform the replication. So replications is like, suppose that you are creating two ports of the same applications. Maybe this is because suppose that if your applications fail, then the other port will serve. Sorry. And then the health monitoring is for checking like whether the port is port is healthy or not. Key value database. So etcd is the one which is stored. So it's a database which store all the information about the cluster. So if you want to doing some work on the cluster like resource for scheduling, then you use the etcd to get all the information. And a worker node, which is for running all the applications or the pods. And the kube proxy is the one communicating with the master node. And the manage ports. So kubelet. So kubelet, where is kubelet? Kubelet. So kubelet is the one which is interacting with the container Docker container engine. So kube proxy is communicating with the API. Kubelet is communicating with kube proxy, and then with the Docker for deploying containers. And then you have the container engines, for example, Docker or RKT for deploying pods. So this is the architecture. And the Minikube, as the name tells, it's a Kubernetes cluster, but it runs the master node and worker node in a single virtual machine. So it's a mini, Kubernetes. So this is good for simple testing and simple, study, and you can try in your machine, easy to manage and easy to tear down the cluster. So that's all. Thanks a lot for listening. I can answer your questions.
Thank you, sir. Thank you so much for the lovely presentations. I hope our participants got so much knowledge from the presentation. So let's take some questions from the participants. Okay.
Yeah.
So first question is from Shobik Pratihar, that in the architecture diagram, there was this container runtime mentioned. How is it different from hypervisors?
Yeah, the difference is that the hypervisor is the isolating the hardware, right? It's creating an abstract layer of the hardware. So the difference is that a container is not creating an abstract hardware layer. So that is the big difference. So sometimes there are questions like whether hypervisor container engine is a hypervisor, whether Docker is an hypervisor or not. No, it's not the same. They are different. Container just isolate the processes. That's all.
Okay, sir. Thank you so much. I hope Shobik got your answers. And the next question is from Nishkal Prakash, and he asks that what are some ways where isolation fails when using Docker?
Yeah, that's a good question. I mean, Docker actually properly, Docker properly unable to isolate the resources. I mean, when in terms of kernel, I mean, it basically shares the operating system base kernel. So it does not, isolate properly. It just some of the resources it isolate. So, there is a criticism of Docker also, and there's a unique kernel called unique kernel, which is for each application you have the kernel of itself. So then it gives the proper isolation. Then it doesn't share the kernel. So the solution, probably 5 years after this, when the container will not be popular, then maybe unique kernel will come and solve the this solution. Yeah, hopefully that's the answer.
Thank you so much. Next question is from Syed Sainawa Sahil Imani, and he asks that does Docker also provides different network namespaces and relation to technologies like SDN, OpenStack to Docker containers? How does it compare to other containers like jails?
Yeah, Docker is using different namespace, network namespace for isolation the network resources, and relation to technologies like SDN. So if I understood correctly, SDN is for network. They have this control plan and data plan, and some of the control plan can be deployed in the Docker. So that's called network function virtualization, where some of the networking applications will be virtualized. And OpenStack is actually a hardware virtualization platform. With OpenStack, you can create multiple VM. And Docker container, we already know. I mean, Docker container is for container isolation. It doesn't create a hardware. It just isolate the processes. And Jails, I never, sorry, I never heard this. Maybe it's Jenkins.
Okay.
It's sorry, the Jails. I never heard about this.
Okay. So I hope you got the answer.
Yeah. Next
Yes,
question. What is Union file system?
Union file system? Is it something similar to normal Windows file system?
It's no, it's a different. I mean, it's the Union file system is like you have the multiple layers, and then as you mentioned earlier, in the file system you have multiple layers, and you can combine all those file system and together, multiple layers together. So this unique features is what Docker is using to combine the layers, since all the layers are read-only. And so they combine with the Union file system to show a unified, file system. So.
Okay, sir. Again, he is saying that is this container file system same as Union's file system? Okay, so that is the same.
Yeah.
Yeah. Oh, then next question is from Nishal Prakash again, and he is saying that what is the difference between volume versus bind mount?
Bind mount is also is a kind of in the volume, in the bind mount you can create anywhere. You can create anywhere. I mean, maybe anywhere on the host operating system. In the volume, it's a Docker. It will be stored in a secure place where Docker keeps all the images. So there's something called Docker storage directory where Docker keeps container information. So it's a secure place, and the volume will if you keep in volume, then it will be more secure. That's the difference.
Okay, sir. Next question is from again Syed, and he is saying that if using the same container FS, can the one container read or write from the FS of another, say like 2 copies of the same image?
No, I mean Docker will not allow that. I mean that's the point. I mean,
okay.
This will not be Docker. I mean, then it's conflicting. There will be conflict. Usually, okay. Docker creates for each layers. Docker creates one unique read-write layer. I mean,
okay, so next question is again from him, that how well does registry scale to large-scale concurrency?
Yeah, I mean it depends on the how the registry is how the registry is deployed. I mean, how it can be scaled. I mean, it's depend on the server. I think you can scale. You can for improving performance, you can scale the server itself, and you can create multiple cache also there. You can read many papers on that, how to improve performance of the registry server. Registry is nothing but a web server where you can where they store the image layers. So there is a performance issue, obviously, and yeah, there are a lot of works on it.
Okay, so Thank you, sir. Next question again from Shobik Pratihar that does Kubernetes require its own network driver?
Does Kubernetes require? Yeah, I mean, for networking of multiple ports, the Kubernetes need to in Kubernetes you need to use network plugins. I mean, different network plugins.
Okay, sir. So next question is very interesting. He is saying, Nishkant Prakash, that if possible, could you share some experience where using Docker proved useful?
Yeah, obviously. If you deploy application in the VM, you create the virtual machine, and then you deploy the application. Just check how much time it takes. Creating the virtual machine takes multiple minutes, and then you deploy application. You deploy in the containers, it takes in few seconds. That's all. Suppose that you want to deploy a web server, Apache web server. Normally, what I will do is that I will create a virtual machine from the public cloud provider, let's say AWS, and then I will create a VM. I mean, I will install the whole operating system. Installing whole operating system takes a couple of minutes, and it takes lots of space also. If you have the container, just you run Docker run and then the container image. It takes few milliseconds. That's all.
So we also got some question from YouTube also. Like Ishta Kapoor has asked that please explain difference between Docker and Kubernetes.
The Docker is one which is managing the containers, in the same host, running in the same host, and the Kubernetes is an orchestrator which is managing, containers in different hosts, which is running in different systems, and actually Kubernetes is using Docker to deploy. I mean, it can use Docker or RKT. Basically, it is Kubernetes is deploying containers with the help of Docker.
Okay, sir. The next question is, how do you see Docker technology in a few years to come?
It's very difficult to predict, but hopefully it will remain a couple of years. And I mean, technology changes. I mean, and then you need to learn new technologies. But the idea is almost same. I think if you talk about the orchestrator, I mean, Kubernetes orchestrator, it's it's the same as the cloud orchestrator, OpenStack. I mean, they all do the same kind of operation functions.
Okay, sir. Thank you so much. I hope that all of the participants got their answers. So, okay, sir. Another question is from Deborshi Basu that he is asking that if multiple Docker containers are running multiple microservices where multiple instances of shared images are being processed, how to provide an end-to-end secure access in this case?
I mean, the images are shared, so read only. So no one is writing on those images, so that there is no issue of security. Right. If someone is injecting that image with some malicious call, then only the security will be broken. Right. And since the Docker images are read only, so that means there is no issue of secure. But there may be security issue if from one container to another container, there is some injection of code on the container read-write layer, because the read-write layer is it's where you can put something. So, but on the image, there is no such issue.
Okay. So it seems like it's a very safe software. So, okay, I hope you all got your answers very clearly. Thank you so much, sir, for answering the questions. And also now we will start the demonstration and hands-on experience. So be with us and enjoy learning. Thank you, sir. Over to you.
Yeah, there is a one question. I would like to know your view on using Docker in blockchains with any example. Yeah, I mean, right now I am doing that. I mean, I will try to deploy blockchain with Docker, and we'll see. I'm not. I'm learning blockchain right now because of my work. So yeah, we'll see.
Okay, sir.
Sorry.
Okay, sir.
So
Now,
now let's move. We don't have much time. What?
thanks.
Sorry. What? Sorry. Okay. Now, how do I close this one? Oh, okay. Now we have closed. Okay. Now we will present. Okay. Can you see the window? Okay. Can you see my screen?
Yes, sir. It's coming.
Yeah. Okay. Now we'll go to the hands-on experience, hands-on exercises. So I created one GitLab repo, and here we have all the exercises. Okay, and maybe you can try. I don't know how you have you installed the the VM properly in your machine. Okay, I hope you have installed all the VM, and you have cloned the this repository. So we'll use this repository to do the hands-on exercises. And I have the Docker. Sorry, I have this Docker VM running in my system. And right now I will do the first exercise, and then we can see like whether you can do or not, whether you have problem or not. And if you have problem, then you can write on the chat box, and you know, my colleagues are there, you know, to see your questions, and then I will try to answer. So the first installation, so I have given a couple of what are the requirements, and then we'll install first Git and to enable this the clone, and then we'll do the installations. Yeah. So the apt-get update, so you have to update the repo. Password is Docker. And then we will install the, you know, some of the packages that we'll use to download the Docker from the repository. I hope you can see and do these operations one by one. And then we'll import the key. Sorry. Verify. So this is to verify whether the key has been. And then we will add the, you know, the repo, from where the Docker binary will be downloaded. So this is the key. I mean, you need to add this key. Otherwise, when you run this command, it will show that these are not available. I mean, these packages. So you need to add this repo. Okay, so I have added the repo, and then we'll download and install all the binaries. Okay, this is the container D, which is in the low level. The container CLI, if you remember, then this is the command line package. This is the container engine, and this is so you have the three three packages here. दिख रहा है? Sorry. Okay, so
इसमें तुम्हारा वो वेब पेज ही दिख रहा है.
अब पेज ही दिख रहा है ना? Okay. Okay.
हाँ, सही है.
Can you see the terminal? I was actually installing here. I will do it again. No, it will take time. Sorry. Yeah, I was installing here, but I think it was not shared with you. So first, you have to do the update. This is for the repo update, and then you have to add those you have to add these packages to download the repository. Sorry, the packages. I mean the Ubuntu package. Since I have already installed a few minutes ago, so it is saying that it's already there. And then you have to add the key from Docker. Okay, and just to verify. And then this is to add the repository or the downloading the link from where Docker binaries will be downloaded. So you have to add. This is important. Otherwise, you will not when you perform this, when you give this command, you will not it will say like these packages is not available. Packages are not available. So I have already added. So once you done that, you will see this this output. And then you have to give this command. This is to download the binaries from here. I have already done that. So this is that's why it is showing it's already in the newest version. Okay. So if you are doing right now, okay. Okay. If you are doing now, then you will see. I mean this. You will see this output. It will download for a couple of files. It's the size is around 450 MB. Now we have, so in this system we have all the Docker packages or Docker binaries. Now we'll add this Docker. We'll create a Docker group. and then add the group to add the user to the Docker group. So then we will create we'll see Docker info to see whether it is properly installed. So you see the Docker info command here. It is showing how many containers are present, how many images are present. So this is information about the Docker which is running in this machine. Docker version is here. Sorry, this is not. Okay. So if you have any questions from here, no questions? Okay. Yeah, so if you have, if you are running different operating system, yes, you will get, you need to follow different procedure. Yeah. And this one is for Ubuntu operating system. So if you are using the virtual machine, then I think yeah, this will be easy. Now we'll do the second exercise. I hope you already have installed. If you have a problem, then you can share me. Otherwise, I will go the next. I will show you how we can handle containers. So we have Docker already installed, and then we can create a container. So I already mentioned earlier, it is we will use Docker run command. Okay, and Docker run and the hello. So the base image and the tag. Hello world is the base image, and latest is the tag of the image. So Docker run hello world. So I will give then the latest image. So you see in unable to find the image. So this means the image is not available. So earlier we mentioned that if you want to create a container, you need the image of that container. So earlier in this system, we don't have the image, so it will download. So first it checks the image is already present or not. It says unable to find. So the image was not there. Then it start pulling the image from where? From Docker Hub registry. So it was downloading the image because the image is very small. So downloading takes only a few seconds, and then it started running the container. So the output of the container is this. Hello from Docker. This is the output. Okay. So you see that the image is image was downloading, and then it create the container and then stop. Now we'll see whether so Docker PS is to see what are the images are present. So let's say here, sorry, what Docker PS. So Docker PS shows all the running containers. So since we don't have any container running, so it will not show any anything. So if we give Docker PS A -A, then it will show all the containers existing the exit one. So you see, you have the this container, but it is already exited. So it is done. So we'll run another again, this one, Docker run hello world latest. But here you see the difference. Here it is not downloading the image. So you see that here it was downloading the image, but we don't see here downloading the image because image is already present. And again, we'll check all the containers. So you see another, we have another container which is already stopped, exited. So this is how you deploy a container, okay? And how you create you see all the containers. One of the thing here is the container ID. So this is the identifier where you can, this is the unique identifier of the container, and you can use this to interact with the container, okay? So if you want to change something, then you use the container ID. Suppose that you want to remove the container, then suppose, let's say these are already stopped and now it is there. So I want to remove docker rm, and then you use the container ID. Now we'll see. So this container is already deleted. Okay, we'll do same. So we don't have any container. Okay. Now we'll do something. We'll see. Okay. Now we'll see already running containers. Okay. This one is using something called. So this one is using NGN's web server. So NGN's is as a web server which. So we will deploy a web applications here. So it was already downloading the image, and then it has created the container. Okay, and now we'll see, and the container is already running right now. So you see the container is already running now. And okay, so now we have a container which is running. We saw, so here I gave a couple of other parameters, like there's name. So this means we are providing a name on of the container, and -d is to detach. So once it is created, it will running on the background, and the container will run on background. So I gave a couple of parameters, and this one is for exposing the port. So we'll see later on this. So we have the already running container. So now we will do a couple of other things. Okay, now we will see attach. So attach is for suppose that you want to interact with the container. Let's say Docker. Then you give the container name. Okay. Sorry, this is there is something wrong here. Probably it will take some time. So it takes some time to attach the container, and we'll see other commands. Okay, we'll see other commands. We will stop the container. So now we have a running container. We'll try to stop the container. So we'll use docker stop, and then the container ID or name. We can give the container ID as well. Now we'll see what. Now you see the container is already stopped, and we'll see with the -a argument that it has stopped, and then it is on the pause mode. Now what we'll do, we'll restart the container. So mind you that this container is stopped, but it has not been removed. So we'll do restart, and we'll give, we can give the name or we can give the ID as well. Okay, now we have the container running, and then we can see the container is already up for 6 seconds. So with ps command, you can see that it is up for 13 seconds. So here we can see the container is running. Container, we can pause the container. We can restart the container. We can inspect the container informations, like you want to. Normally, you do inspect, process information, right? If you are running applications where you check the process information. So you can do the with the container with the inspect command, and we provide here either the ID or or the name of the image, name of the container. So here you can see all the information about the container. It's too large, too many. Created, yeah, image, host name part. So we'll not look into this, I mean, in detail. Docker state. So Docker state is resource uses of container. So suppose that you want to see how many CPU it is consuming, how many memory it is consuming, how many cores, how many process it CPU it is consumed, and all those things you can see with the Docker states command. It's like the in top command of the Linux. Docker state my sorry. So here you see it's showing how much CPU it is using, and the memory out of 2 GB, 2.46 MB, and network IO. Network IO means how much it is communicating with the internet within the network interface, and block IO as well. Okay, now it's like showing top command. Here you see in the Linux top command, you can see all those information. So you can do the same thing with the Docker with the Docker states command, and then so if you have, so Docker diff is for change in the container. So if you have modified something in the Docker container file system, then you can check Docker. So here it is showing in the Docker image which are the files has been changed. Okay, so using diff you can see all those. These are the files had been changed. Then you want to copy something, so you can do that. I mean, you can copy some file from here, from the local file system to the container file system. Inside the container, you can do with the Docker CP. Let's do something. Docker CP, and the source file, maybe. Oh, this is these are. Let's see whether it can be done or not. Okay, this one is not, app is not present. Let's see bar, but operation not permitted. Okay, this is no, I am not able to copy because this is some of the resources, some of the files that I cannot access. I mean, but if you want to check if there are some files that I can I can access, that means I can copy also. Docker exec. Okay. So, permission not denied anyway. And then we can remove the container. We have done that. So these are some of the exercise that you can go through. I mean, in your system, and you can see what are how you can deploy containers. If you have, does the -p argument forward the port? No, yeah, -p. So there is one question, good question. -p is to forward the port from, yeah, this is just 1 second. So I think you can now see better. Sorry, I didn't notice this. So we saw. So we did some of the commands from here, which is related to container, actually container related to container creation and container remove. Yeah, and now we'll see next Docker image. So how we can pull a Docker image. Okay. So Docker, you can download the Docker image with the Docker pull command, and yeah, we can do that. Docker pull. So let's pull Ubuntu image. So it will download the image layers. So by default, it will take the latest as a tag. So we need to provide, you know, tag also. If we don't provide, then it will take latest. So we can list out the images with the Docker images command. You see. So earlier we used hello world and then nginx for the deployment, and then we downloaded Ubuntu image. Okay. So you can use the Docker images to see all the downloaded images here. So let's pull Ubuntu 18.04. I don't know whether they have the image. Yeah, they have this image, Ubuntu 18.1. So you can download different version of the images. Ubuntu 18.04. So this is the version or tag. So you can see the image. So you can you can go to Docker Hub, and then you can download any CentOS. Let's say CentOS. So you use the Docker pull command from here, and then you just keep Docker pull CentOS, and then it will download the images. You see image size is compared to VM, it's the nginx 133. So if you deploy this nginx in the VM, then you need to deploy the VM, and then you deploy this application. So it will take minutes. Docker history. So if so the Docker history tells what are the modification has been done on that image. So you can use the history to see nginx. So nginx, it was created in 12 days ago, and then it did a couple of modified. Someone ran this. Someone copied files, and then ultimately this is the last update. So it can see with this, you can see the updates have been made on this image. So you can see in Ubuntu. Yeah. So if you are building a new image, so if you are building a new image, then you can see all the previous changes with the Docker history. Now you can remove an image. So you have to use the Docker RMI, and then you just give the Ubuntu, let's say 18.04. We don't need this image. You just remove the image. Okay. Then you don't need the CentOS. And then now you list out the images. You will see we have only a couple of images right now. So we know how to download images. We know how to check history of the images, and then we can remove images as well. If you want to remove all the images, then you do Docker prune. Okay. purge, docker purge, I guess. Anyway, I don't know why it's not working. So we'll try to create an image from the Docker file. Here is and then we'll see how the image is created. I mean, we use the image. So for this, we'll use the exercise. We'll use this repository, and then here you will find a couple of Docker images. So if you go to the image builder, then you will see one Docker file here. So we'll use this image, this file to create the image. So if you see the image here, the Docker file, it creates from the Python base image, and it copies a couple of files in the image to be created, and then it exposes the port number 8000, and then it perform this command. This is the simple Python command to start a server. Okay, so we'll do this here. Let me clone the repo, git clone. Okay, so we have the here. Okay, and then we go to the image builder. Okay, and then you see the file, Docker file here. So from Python is the base image, and then we copy the two files which are here, and then we do the expose. Here it will be exposed to the container. The container will expose this port, and then we have the Python, the command. So how to build the image? So so you will find here, over here. Okay. We are running out of time. Docker build -t. So you give this command -t, and then you give the image and the tag, whatever you want. So I gave Docker build -t, and then my app, then the latest, then you give the dot button. It will start building the image. Docker will build. So Docker is downloading the Python image. So you see here, we are using the Python base image, and Python image was not there in the local file system. So it will download the image first. Yeah, it's too big. Python, how good. Takes a couple of seconds. So it will first download the image, and the Docker will execute each of the instruction. Okay, now we have the image. You see? So it is doing all the steps. Step 1, 4, it is downloading the image. Step 2 is copying this in the image layers, and then we have all the instruction, and now we will see Docker images, and then you will see our image has been created. Okay, you see my app, latest, this, and you can see the history of this image. Sorry, my app. No, I okay. I have done latest. Oh, I had some mistake. So I have so you can see the image. Okay, so I have added couple of things here, right? Yeah, I have copied some files. I have exposed the port, and then I did lastly I did with the cmd this command. So you can see the changes here, the Docker history. So we have the image, we build the image, you can see the image. Now we will upload this image in the Docker Hub, okay? So we want to share the image, right? With our, so you will see like you will create an account here, and then maybe, I don't know whether I will just show you with my, okay, shit. Yeah, I have couple of images, so you can share the image with your account. You just have to use the, so you, for sharing the images, you need to use the Docker push command, but you have to modify the image name with the username / my image, your image name and the latest. Otherwise, Docker will not accept. So you have to keep your username first, and then the /, and then, so that is nothing but the tagging of the image. Tagging of the image with Docker tag command, you can change the image name. Okay, so we'll just do that. Docker tag, and so what you will do, my app, and then I will use my username. Okay, and then I will the image name. So you can change here. So I have changed the image. So I have the another image. So this one is using, this one has the user ID of the Docker Hub. So if you want to push the image, you just have to rename the image with your user ID before this /. Okay, that's otherwise the Docker Hub will not accept. Then you do the Docker push, and give the image name and then the tag. So 12.0, 21.02. Now you see request also. So it is and so I have to log in. So Docker Hub is not accepting the push. So first you need to log in. How you can do that? Docker login, and then you give the username, and then you give the password. Okay, now I have already logged in the user Docker Hub from the command line. Now you can push. So now the Docker Hub is accepted my command, the upload. Yeah. So now I have pushed the image. Now you can copy this image. Sorry. Now you can deploy this image. You do deploy Docker pull, and this. Now you can pull the image from in your system. So I will remove a couple of images from here. So okay. So now you can try. I mean, we don't have much time left, so we just leave it here. This Docker image pull and push. So we know how to build image. We can push the image, but we have to tag the image with the username and my and container port. So we can also expose the container when we created the container port. Is suppose that you are running an application inside the container. Now you know that the container is always isolated, right? That means any other application cannot access the container. Suppose that you want to run an web server inside the container, and it is using port number, let's say 80, and then you want to access from the outside, then because of the container is isolated, you will not able to access. Okay, so we'll do this with an example and see whether it is true or not, and then we'll do something called exposing the port, or port forwarding. So port forwarding is nothing but you can access the container port. You can access the port inside of the container from outside. Okay. Okay, I have already running a couple of. I need to remove this, and then we'll try. I have to stop. Yeah, so we have stopped the container and we will deploy this. Yeah, and then we will try to use, let's see, whether I can. So I'm not able to access the container. Okay, from inside the container you can access. So let's see Docker execute. This will actually, hopefully it will work. Yeah. Now what I have done is that I have executed a command inside the container. Okay, this is not from outside the container, from the inside the container. What I have done is that I have curled the nginx web address, nginx server, and then you can see that I got a reply. Okay, so this is from here we can see that we cannot access the server from outside the container. We have to go and execute inside to access the application. But our intention, what we use container, we want to expose the if we need, for example, here we are running a web server, right? And then that means we need to access the web server from outside the container, and so we can do that. We can do that with something called exposing the port or port forwarding. And then we here you see that we have forwarded the port to another. We have forwarded the port to the outside the container. So what I will do is that I will remove the container right now, and then I will next time when I deploy. So let's say I will deploy this container, but I will use another parameter which is for forwarding the port. Okay, now this container is already running. Yeah, it's already running, but we see we have forwarded the port, and then we will do the curl command from outside the container. Okay, this is from outside the container, and then you see that we can access the server. Earlier we were not able to access connection, so we did the same thing, but we cannot access the server. And if we execute from inside the container, it will this output will come. So no need to do that. We already know that. So this is how we expose the container out to the outside using the port forwarding. Okay. So now I will just stop this and then the remote. Now we'll do something Docker volume. So earlier we mentioned what is Docker volume. It is to share the container files, shared files inside the container from the local host. It can be done from the local host, or it can be done from the memory as well. So from here we will create a one volume, and then we will share to the container. Okay. So these are some of the Docker volume command. So this is to list out the volume. So we don't have the volume. We don't have any volume, so I will create a volume. Okay, my volume. So I have created, and then I can inspect the volume. I have created a volume, and the volume is stored here. Mount point from, so here the files will be stored over here. Okay, and this directory will be shared to the container where I will use this volume. And you can list out the volume. So I have created one with the my volume name, my volume. And now here I will use I will deploy a container, but I will use the volume. Okay, and see, I mean, what we can do. So let's for this I will use another Docker image. And so if you have seen the other previous Docker file, and in the previous Docker file we copied some of the files, right? Now in this case we will not copy the files. Instead we'll mount from the local file system, we'll mount to the container file container. Okay, this is the difference. Got it. Other instructions are same. These are same. Only thing is that I have added working directory, and I have removed the files which are the instruction which copy files from the local file system to the image. And so we'll go to the image builder 2, and you can see Docker file. You can see the Docker file. I will create a Docker image. Docker my app to lattice. Then we have the already Python base image, so it will not download. The one instruction working directory is app, and then we expose the port 8000. And then we give the command. Okay, this is now we have the image, but now in this image we don't have the files index.html. We don't have the file index.html, docker.png, and so we have to mount this inside the container. Okay, and so we already have the volume, right? We already have my volume, so we will use this my volume in the container creation. So I will copy these files which will be used, which will be mounted. So now I will do what? So in this volume, we already have two files. Okay, copy docker.png, then index.html, and then we will we will mount these two files inside the container. And how we can do that? When we deploy the container, we will pass a parameter which is to use the mount. Okay, so this docker run name, so we are giving the name web server, and then this mount, it will mount a volume, and then it will target in which directory you will mount. Okay, and then this here we are exposing the port. So we already know this minus port is for exposing or port forwarding from container to local file system. So we will use this command. And the image name, what was the image name? Yeah, sorry, where is the, yeah, my app to lattice. And volume name, my volume target. So we will, so why I gave dot app slash app, because in the, when we created the image, where the file, so we created the image, you see I gave the working directory slash app. That means this command will be running on this app, sorry, this directory, sorry, slash app. And we need to mount the volume in this directory so that the server can access. Now we have the image, sorry, we have the container, and we will try to curl. And then we will use the, so you see I have able to curl the 120 the Python web server, and then you can see the index.html. Okay, the index.html, this is the content. Okay, and yeah, that's all. Now I will try to remove this, my app to latest, sorry, web server. Yeah, it takes time. Yeah, if we remove the port, if we remove the mount, it will create the container. But when we curl this, it is not showing the index.html. It's showing something directory listing for, it's showing the default one. Okay, it's not showing the index.html. So we haven't mounted, that's one. Now with Docker stop. Yeah, there is a question from Shahnawaz. Okay, how do we run different images on top of another one, like running a Python image running on Ubuntu? Actually, the Python image is using basically some Ubuntu image. Okay, so you cannot you can create an image on top of an image, right? But you cannot actually yeah, I mean it basically it's using the Ubuntu image. So it, when the Python image was created, it was basically using some Ubuntu based image. That's why you see the Python image has multiple layers. Why does stopping container take more time than creating? Yeah, I mean it takes it depends on the yeah, it depends on the hardware also. Here I'm using only 2 gigabit of RAM, that's why. And sometimes the application like web server, it takes time to stop the application, that's why. So Minikube, should I so I will show you the Minikube installation. Okay, so Minikube is the first, you need to install the Minikube, and I will just show you. So we have the Minikube already downloaded. I have this Minikube, sorry, I need to move. So I have the Minikube, and then I will just install the Minikube. I think we have already 2:30 here. That means 7. But I will show you. I will try to complete This is for install. This is for the Windows. If you want to use Windows, then you use this command. But and then kubectl. So earlier I have mentioned kubectl is to interact with the Kubernetes cluster. So we need to install the kubectl as well. You download the kubectl binary, and then you give the command. Okay, and then you can check the kubectl. Okay. Now I will start a minikube. So you give the minikube start command. If you are running inside the container, you don't give you just give this parameter VM driver. So it will take a couple of minutes to download the images. So what actually it does is that when Kubernetes also using containers to run their every components of the container. Every components of the orchestrator. So Kubernetes, in the case of minikube, so minikube is using different containers to run all those components. So when you deploy minikube first time, the Kubernetes minikube will download all the images first. So it will download all the Kubernetes components, and then it will deploy. So that's why it is taking a couple of minutes. So downloading Kubernetes version this. So it's using version 1.20.2, and it takes a couple of minutes. So we will just have to wait. And then we don't have that many. I think we are going to finish. So once we have the creating Docker containers, so it will take a couple of minutes to create the container. Okay, I just want to know whether should we continue this or we just stop here, because it's already, I think, over. What do you think?
Sir, if you are comfortable, then I think we can take some more time.
Yeah. Okay. So I will just continue this. I mean, it doesn't take that much. So we have already deployed the minikube, and then we will show the minikube status. Okay, minikube is running, control plan is running, host running, kubelet is running, API server is running. Okay, so we can see the status, and then we can. So you see kubectl. So we are using the kubectl to see all the ports. So kubectl get port. So it will describe all the ports running. Okay. So it is. So you see the couple of Kubernetes components are already running here. It's like Docker PS. It takes a couple of time. Yeah, now you see all the components are running. Yeah, all the components running. If something is wrong, then it will show 0 / is the number of ports, and 0 is the how many are running. So in etcd minikube, so earlier it was taking a couple of seconds to start. So now we have all the ports running. So in the Kubernetes case, Kubernetes identify as a port. So you remember, you can think of container of Docker as a port in the Kubernetes. And then we can stop. We'll do this later on. We can describe the minikube. No. So we will create a deployment. We will create an nginx with the kubectl. So we use the kubectl to deploy Orcas applications in the Minikube cluster. And you see the command create, and we have the deployment command, and we give the name nginx, and we will use the image name nginx. Okay. And you can, instead of doing writing in this way, you can write in a file, in YML file, and you can give various configuration files, how many replicas in which node you want to deploy. So you can give, but for the time being, we'll do just the simple one. We don't have time. So we have the deployment. We already created the deployment. Now we will see running ports. With this command, we will see how many ports are running. Okay. Now you see one more port has been added, nginx. Okay. And then it is create. It is taking time because it will download the nginx image, and then it will create the container. So now you see in the next, after a few seconds, we have the nginx running, right? And you see we had created only one port, and the status was container creating, and then we have now we see in 29 seconds it is already running. So we saw the verify nginx ports are running, and then we need to expose here also. So Kubernetes provides a different way of exposing. Okay, one is cluster, one is the node port. The node port is for exposing to the outside of the cluster. So, and from anywhere you can access the port, the application. So for this, we need to create a service, and then we need to give the type node port, and we give the name, and then so we have created the service. So you see which are the service we have exposed. We have exposed the nginx, and then we with the IT inside the cluster and 32667 TCP. So you can use any of the node port, any of the cluster node with in the node port, and then you can use the cluster node IP. So you can use one of the node's IP address, and then you can use this port number to access the service. Okay, and how to get the IP address of the this is the IP address of the node, master node. So we use the curl command. We give the IP address of the one of the node of the cluster. In this case, we are running master node and worker node in the same machine. So we give the IP address, and then we give the expose port number 32667. So now you can see we can access nginx. This is the HTML file. Now we just remove the we will delete just to see the difference. We will delete the nginx. Okay, so, the service. So we have deleted the nginx, and then now we'll try to. So we have only the one service, and we try to access. we are not able to access the from outside the cluster the NGNX port. Okay. Now we can see all the ports. You can delete the deployment, delete deployment, and then you can give the name. Okay, we have deleted the NGNX. So it is now showing terminating. You see, I have deleted. It takes a few seconds to terminate, and so it's not running anymore. So that's all how we can deploy. We can install Kubernetes in one single machine. You can so you can show the graphics also, but we don't have here GUI in this machine, so we can't run Minikube dashboard. We can stop the Kubernetes cluster. Minikube, okay. So there is some. So it's terminating all the ports, and it has stopped. Now we can do Minikube status, and it will show. It will show all the hosts, all the kubelet, all the components are stopped, and then we can delete. We can delete the cluster. So we have deleted the cluster, so we can again do the same thing from here. Minikube start, and then you can use the kubectl to get all the ports running in the cluster, and then you can create deployment of an application with this. And the service is to expose the app out to the outside cluster. So that's all from here. Hopefully you can do it. I mean, if you have some problem, then you can write to my email address. I gave. I think I can write here as again. Arif CH19. Oh, yeah, this is my email ID. So you can mail me. I mean, and then I will try to reply. Yeah, hopefully you learn. I mean, Docker, Kubernetes from here. Hopefully it will be useful. And then yeah, exercise, do it. If you are not able to do it right now, you can do it. I mean, in your yeah, later on as well. There is a couple of questions. Is not Minikube supposed to have its own dashboard? Yeah, I can. Yeah, you can do it. I mean, you can show the dashboard with Minikube. This dashboard, it will expose the service. But I don't have the. I mean, GUI, so I cannot. So that's why. Yeah.
Thank you, sir. Thank you so much. I hope all the participants have got a lovely overview on Docker and Kubernetes. And it was a lovely session. And the hands-on training was also very useful, I think. And if you have any questions, as sir has already said, he has provided his email ID in the chat box. Please find it. And if you have any question, you can ask directly to our speaker. And thank you so much. So, sir, I just want to say that we just want to take a group photo with all of us. So all the participants are requested to turn on your camera if possible, and we will just take a group photo to keep it as a memory. So please.
I will stop the presentation.
Yes, sir. Thank you, sir. I would like to request our team member, the photographer Sukanya, to take a group photo of us.
Yeah, I can't see my. Am I visible?
Yes, sir. You're visible. You're visible.
Yeah. Yeah.
Sukanya, please inform us when it is done. Okay. Everyone is turning their camera. Please keep your camera on.
It's done.
Done? Okay. Thank you. Thank you so much, all of you.
Yeah, thanks a lot.
Thank you, sir. Thank you for joining us and
Yeah.
taking out time from your busy schedule. Thank you so much. It was a lovely experience. Thank you so much, sir.
Thanks a lot. Okay.
Thanks,
Have a nice weekend. Enjoy the yeah. Bye bye.
Bye-bye, sir. I hope all of you have enjoyed a lot and stay tuned for our next event also. You can also check our Facebook page, YouTube channel, and if you want to take the recorded version of the session, you can check the YouTube channel too. So you will get a very crystal clear view from there. So thank you so much. Thank you all. I just want to end here. Thank you.